Well, I'm going to have another go at the ESS Assistant, which is now just sitting there waiting for the grid to go on. And it says, oh, it should be hovering around 0, but not exactly on 0. So I thought, well, hold on, it's more like a 50% power usage from the grid with a 50% power usage from the solar and battery. That's why we turned it off. And they said that it's a minimum state of charge. I know it's set very high for battery preservation, but it's probably interfering with the ESS Assistant. I think if it goes below our minimum state of charge, possibly, I can't remember. It was pulling 50-50. Anyway, something very wrong with that. We've got to give it a go because then we can leave the grid on. Now, there's one thing that the Victron has that the other inverters don't have: power assist. That's what it's doing. It's using power assist to combine with the self-consumption 50-50 at the moment with the current setup, and that's why we turned it off. But with the EV charger, instead of having a changeover switch, just have this power assist reenacted or enacted in conjunction with the ESS Assistant, so that if it ever goes over 5 kilowatts, the maximum output of the inverter, per inverter that is, there's 6 of them there, totaling 30 kilowatt hours, which would only happen if you had your car being charged at 22 kilowatts and your big air conditioner on at the same time, and so on. So this is going to save a changeover switch. So go back to what we're looking at. So I'll change the minimum state of charge in Victron Connect, of course, because Victron configuration is usually for more advanced settings. So that should be done easily. The other thing is this video here. It seems to be pretty good. They're talking about getting into Victron Connect here as well. Advanced settings. Prioritize other energy sources, because he's explaining that the Victron originated on ships. So as soon as you went to shore, you plugged in the grid. It prioritized the grid rather than some sort of solar battery system. But now they've got all these other. So that's the base of the Victron programming, and so that's why it was charging the batteries. So from the grid. So we've got to prioritize other energy sources. Obviously, it can be done in Victron Connect or in a VE configure. Obviously, Victron Connect is easier. This video is very good. It's explaining a lot of things that didn't make sense to me because of ambiguous information. Here we've got virtual switch, which is either or. The important thing is they can't work with an assistant. So here's the other tab for an assistant. Virtual switch is priority. In this one, he's set this virtual switch. I think he set it to switch over to the grid when it reaches a maximum power output of 4.5 kilowatts here. And then he has the off as well when it gets below the load. This is, by the way, the load gets below a set point as well. Where is it? He had it open. There it is. When it gets below, he set it for 1100, but I'd set it for 4, you know. But the problem with this is it's an either or. It's a virtual switch. It's like a changeover switch in the inverter, so you don't need a mechanical one. So if it gets overloaded, it will switch to the grid rather than power assist. Now, what we want is total self-consumption, and then only to get additional power from the grid using the power assist function that the Victron has in order to assist rather than, again, do a switcheroo. So the virtual switch is no good. He's also gone into assistance, and one system is a programmable relay, which is doing the same as a virtual switch. However, it's mechanical. So that, and then he goes in and wires up some stuff and whatever, and where is he? He's got his display here somewhere. There it is. Now, come on, where is it? Get there. Past it. Wait. Here it is. He's got AC ignored. So that'll be either on or off rather than coming in at full power of the inverter when needed and assisting with power assist. So that's the setup he's got here. Let's go. We don't want that. We want power assist in ESS Assistant. So let's have a look. You see what he's doing with this relay, external relay function, is using the generator start-stop relay in the Victron Connect to turn the grid on and off. However, this start generator can be used if the tariff allows you to charge the batteries between 11 AM and 2 PM with free power. Very useful through winter, especially when you've got an EV. But better yet, it looks like the ESS Assistant has something to set charging between those hours. Now in Victoria, the retailers do offer this. It's available. It's been available for a few months now, I believe. Free power charging between 11 AM and 2 PM. And that's the way to go. And ESS Assistant, another reason to put it on. Turn it back on again. So let's ignore this complexity here of all these off-grid type settings and shore settings for a ship in dock, and go straight to the ESS Assistant, give it another go, and we'll set the state of charge of the batteries much lower and see if it prioritises self-consumption over a grid assist. So hats off to this guy, because he really knows what he's talking about and explained a lot of things, but ultimately we're using the ESS Assistant. Give it another go. Hold your horses. It may not just be as easily as lowering the state of charge. This new search using AI has said that I have to use other assistants alongside ESS Assistant. So that means I will set a general flag, which is, why they call it a flag? I don't know. It's very confusing. I would use the word conditional formatting or condition rather than flag. Very confusing. So let's say general flag means, this is what I'm talking about, ambiguous descriptions that don't have explanation. So let's just call the general flag a conditional formatting, which anyone who uses a spreadsheet would be familiar with. So when some programmed settings are performed, then this general flag will sense those settings, conditions rather. See, I'm using the word condition. Sense those conditions and respond accordingly. And it says here, this is all internal. This doesn't need physical, contactors and relays to do it. It's internal in the inverter. So it's frequently used along ESS Assistant, okay, to ignore the AC input. So basically we have to set up a general flag to turn on the grid when the inverters are at full load, 5 kilowatt or 4.5, to take advantage of the grid power assist function of these inverters. Found in this assistant section via configuration software. Okay, got it. So it's going to be a little bit more, not specific times, I should say specific conditions. They've used the word specific times. Not good. So I clicked on something on, how to set up these assistants using flags. And I ended up in the blog, Victron blog. Now this is what the problem is with Victron. They have this mindset where, they keep what they know to themselves. I've seen this in American culture. I worked on an oil rig many years ago. And if you knew something, don't tell anyone else, because now you're valuable to the company because you're the only one who knows how to do something. And then Victron has it, and they've got absolutely their asses kicked for it, and deservedly so, because with the battery rebates that have kind of finished in Australia recently, it was all about speed. We need to get these systems in ASAP before the rebates deadline has been met on May 1, and just recently in 2026, and the Fox ESS system was so fast to put in that it left everyone else for dead. And I hope they all suffer for it, because this is crap. This reminds me of this opening credits to Look Who's Talking, where we've got some sperm here going up the wrong tube, you know, just beating their head against the wall. And soon as I end up here, that's exactly what this reminds me of. So, oh well, let's find some actual information. So we ended up back here, and they have used the word customization more or less up here. Well, good on them, but I don't like these ambiguous, stupid words like general flag. All right, well, now we've got to go down the rabbit hole and get some exposition. Use that word again, customization. Stop calling it general flag. Here we have how to add an assistant. And in here we can see an older screenshot. No, yes. It's got self-consumption hub 2. Now that was the predecessor to ESS Assistant. So let's have a look at that. The ESS, this hub 2, self-consumption hub 2, as I said, came before ESS Assistant. But if it does the basics, which is basically only turn on the grid after, 30 kilowatts has been reached on these 6 5 kilowatt inverters, that's all you want. Okay, let's have a look at this ESS Assistant. That doesn't work properly. Here's something just as a note as I browse. Just make sure that the feed in is disabled on the CCGX, which is Victron Connect, the touch screen. Well, I've been sent to this video by Victron. Here's some ESS settings in the Victron Connect as different from VE Config. VE Config's for advanced settings with a laptop. This is done using the touchscreen, as we see here. Wow, this video is 9 years old. Jeez. So, in the mode, either of these two options here at the top will prioritize self-consumption over keeping the batteries charges below here, and that will keep theoretically the meter on the grid at 0 watts. External control is complicated, involving third-party products and whatnot, so we skip that. There is a grid meter there, but there's no need to install it. If 100% of the loads are on the downstream side of the multi plus 2s, you can use the internal meter inside the multi plus 2. And I think that's the case, and should be the case, because these inverters have power assist. So if the load gets above that of the inverter, it can pull from the grid. So I think it's set up that way anyway, because we couldn't use the grid. The circuit breaker to the grid is off, yes. Feed in will be disabled. Phase compensations for single phase installation, where one single phase inverter can pump out power into the grid, not in this case, to compensate for power used on other grids, other phases in the facility for a net zero usage. But I would imagine that would require the grid meter to be turned on, because one single phase multi won't be able to monitor all 3 phases. I think this minimum discharge should be set low. Here it's 20%. I think the par that I have set these for other brands like Day batteries is about 15%. I think the default is 20, but they say, yeah, go 15, but don't go 10. That's the knee on the curve for maximum life. So this is a bit below the knee on the curve. But anyway, 20% is fine, but that could be interfering with our ESS Assistant, causing 50-50 use from the grid. So we'll set that as well, as I mentioned at the start of my video here. Of course, this will be set, no doubt, but better double check it. Battery state, self-consumption. Right, now these might be set wrong. Maximum discharge power, if it's only set to 750, as soon as your loads go over 750, you're going to pull from the grid. No good. Last of all, we don't have a Fronius, so we don't have to set it for 0 feed-in. Excuse me, I will just turn that off, not set that. 750 watt there. I'll just turn that off, and that maximum discharge power option will disappear, and just leave the the battery management system to sort that out. What am I talking about? Okay, he seems to have his gear running pretty well. Look, the grid's hovering around 0 at 9 watts here. The loads are quite high, 2.4 kilowatts, and the inverter's doing 2.3. That must be like a Fronius, and must be a charge controller. Maybe there for dead start. It's only doing 59 watts. The battery's at 100%. It's charging at 65 watts because there's well, anyway, that's what we are supposed to be getting. And this video is 9 years old, so surely it's all in the settings because this ESS Assistant should be working fine. As I said earlier, with or without a grid meter, if all loads, as it says here, you can't read, it's very small, all loads are on the AC out of the inverters, then you don't need the grid meter. Moving along. It categorically states here in optimized mode that the battery should be blah blah blah, but the grid tied, what is it? The grid, red box on the left of the overview, slightly fluctuates around 0, so it should be using 100% self-consumption unless more power is required. In this video, he referenced Hub 1, which is an ambiguous term again. Well, he's saying all it means is that the multi+2 is controlling the charge controller. So that's under the charge controller menu option there. You see, this is what it seems to be doing. Keep the batteries charged mode. It says it will be powering loads from the hold on. He was saying, well, anyway, it's not written here, but he's saying that it will be assisting the loads with the PV, but also from the grid to keep the batteries charged. That seems to be how the ESS is working, which is not working, so we've got to check those settings too. So once again, the grid meter is only needed if you've got a PV meter on this side and some loads on this side, being the grid side, not if everything's on the backup side, as we can see here. If you didn't see my cursor, I'm talking about those icons on the right hand side there, not this one on the left or the top right where the loads are. They're on grid side. And here it is, just to reiterate, ESS without meter, everything's on the backup side. So the meter inside the multi+2 is monitoring the grid because it goes all of the grid goes through the multi+, not in parallel with anything else. So yeah, the grid meter is probably an Achilles heel, so we don't need that. Okay, you got VE config in your computer, you plug it in with the MK3 adapter into the inverter. I believe you've got to do, I think it can do all. System configurator is the other one. This one's for one inverter. VE system configurator will pick up all 6, and then you go to fake target with full options. All right then. Okay, he's in there and he's in assistance and he's setting the grid code for the country. Here it is saying you can't use a virtual switch with an assistant. Sorry, my bad. The grid menu's up here on the left, not with the assistance. Correction. For some reason, he's gone to relay rather than solar self-consumption. What on earth? Well, anyway, shouldn't be too hard to find the ESS Assistant. And the first setting is battery type. Of course, the Pylon Tech batteries have a VE bus BMS. We're talking about 3-phase configuration here. I think this is too old, 2016. They've got the system configurator, VE system configurator now for that. And this is not the color control, it's now the Servo GX. The rest of the video goes with irrelevant stuff. Now let's look at a newer video. So I've punched in ESS into the search on the Victron Energy page and it brings up the same video I just watched from 9 years ago. One last look at dynamic ESS, and this video is only 1 year old, but I want to make a point of, look, this is the actual Victron official channel, and look at this dog's breakfast of wiring behind there. That's absolutely disgraceful. I could really clean this up because I'm an installer, and I've, like, this through the wall stuff cleans things up. I did that on a job recently, and I recommend that. But what on earth is all this other stuff, especially in America? You see their videos, they've got this like ridiculous scenario where you got these steel conduits coming in and out of the AC side, and then you got all this cable dangling down on the DC side because the regulations change from extreme to completely lax on the other end of the scale. It's just incredible. So to clean this up, my recommendation is to, behind that black cover, it should be top and bottom, by the way. This should just be a buzz bar going through from top to bottom. And then it should be bent 90 degrees with a hole on the flat part at the top and a hole on the bent bit tab going 90 degrees to the bottom. That way, when you come through the back of the wall here, you're not doing a 90 degree bend on big heavy duty cables into terminals that are meant to be mounted, let's say parallel to the wall. You want them to be mounted perpendicular to the wall by coming straight through the wall without bending 90 degrees straight onto the tab. So if they had a deeper black cover with a bar going straight through and bent, 90 degrees, like, just an L bracket, but a bar, just a buzz bar bent in a vise 90 degrees, how much would that cost? So you got this... So if you follow the... let me draw a picture. Look at that, I found one. Somebody's made one because it's necessary. Now this bolt cable can come straight through the back of the wall there and straight onto that stud there and tighten up while the screw on the horizontally mounted bus bar attachment point is above there. But that should be inherent. How much is it going to cost? A little bit of 20 millimeters of extra bar bent 90 degrees. And it should extend through the entire Victron because they're very fussy about length of cable. So you want to be able to put it in the top or bottom. So there's vents on the bottom here anyway, so put some vents on the top too so the air circulation doesn't get interfered with. And either right, the top or bottom. I'll tell you why. Here's me in 2025 when I was installing that, and it was really hard to get the RS450, so that one wasn't installed yet. But as you can see, I had to try and... There's a lot of slack of wasted expensive cable behind the wall there because Victron wanted me to keep the lengths the same. Now the bus bar is in this giant box here, there on the right, the big white one next to the batteries. Now I had to keep the lengths from this one here, for example, top right, the same as the one from bottom left, and the way the wall cavities and that worked, which was legal because it was more than, it was a very big space there of 150 mil. Now, so it was automatically immune to tech screws from any cladding on the outside. So, shut up. Now, anyway, it came up and went along. Now, that distance there, a right angle going the length of the multi-plus plus some, up to those DC isolators in between, and then out to the bus bar box to the right, was much longer than coming out of the bottom of this multi-plus above it into the DC isolator and into the box to the right. So I'm wasting this one above. I've got to coil up a whole lot of cable inside the wall cavity to be the same length as this one below it. Well, if the bus bar came out the top as well, the distances would be the same. Now, I ended up putting these isolators on the side of the rack here to meet some Australian regulation. So I actually didn't need these DC isolators, but still, cable length point I'm making still relevant. Path, top and bottom means symmetrical, identical mirror image means the cable lengths will be the same regardless of whether you do DC isolator or not. So now, also in these DC, the reason why I had to put these that's right, smaller DC isolators per battery is because Victron wouldn't let me put the neutral, or should I say the negative, of the batteries through the isolator because their comms system would blow up. So lucky I read that, going down the rabbit hole, doing all this research, down the rabbit hole, what would I, hold on, wait a minute. The rabbit hole in the rabbit hole in the rabbit hole of Victron, instructions. It's just absolutely horrific. So fortunately, while looking for something else, I came across that the fact that the comms will blow up if you switch the isolate the negative. And so then you'll put the 48 volts straight through the comm system, which is grounded to the negative, and blow the shit out of all your multi-plus inverters and electronics. Very expensive, stupid mistake. So these all got bypassed, the negative. So now I don't meet Australian regulations. We're going to have two poles, both the complete isolation. So then ended up going on the battery side over here with these smaller ones.
and more of them, of course, and rendering these of course, and rendering these isolators completely meaningless, apart from the convenience of isolating for the sake of doing some work on them. It's just anyway, and here we are pulling these cables through the wall and then doing a 90 degree. You don't even need to see these cables. Even if the isolators also had that 90 degree, I think I might buy some for the isolators. In fact, if I ever use these isolators again, they're made by a battery company too, Calb. I might buy these, and well, these are for their batteries. I want one that's a universal one that I can put around the corner onto one of those DC isolators and come straight through the back. Because bending heavy duty cables 90 degrees is like retarded. The other thing, if you're in America, like the poor bastard you are, doing everything in steel conduit, I can't imagine that. Ugh. Well, you could probably get around it by making your own enclosure using Perlon there, top right there. See, the garage is built out of Perlon. That's Z section. Get some C section, make a frame, put 2mm sheet metal on the back, put 2mm sheet metal on the front, and drill holes till kingdom come. And not have a single cable showing on the surface, not one piece of steel conduit, that's problem solved. The amount of time I put into this, like, that was really hard pulling through those holes and going into there, and it's not even waterproof. Look at this, I put doubled up there, back to back on that one. That was the RS450 there, and then the other one below waiting to come into stock at the time, very difficult, 2025. Sort of had to fit it in between this door and that Perlon too, just tight for space there. There's the useless grid meter in that box up the top there. That's absolutely chock-a-block full of cables, because all of these, you see, at the time, the MultiPlus 2 5 kilowatt was registered for rebates in Australia, but not the 10 kilowatts. So I ended up putting 6 of them in instead of 3 10 kilowatts. Now the 10 kilowatts are back on the list again for rebates, or pre-approval at least, or illegal to put on. Just getting stuffed around left, right and centre. So you need flexibility, obviously, for these sort of circumstances. Modular upgrades, metrics keep changing all of the time. And look at this clusterfuck, would you? Come on. So if you had a system like I just described, with a buzz bar, or even just add-on attachments made for it, like Calibers made for their batteries, very smart, then everything can go out the back. I'd probably get, 250 mil C-section, Perlon, build a frame, slap it back and front with, maybe the front only needs form ply or chipboard like I've got, and everything goes out the back, big mess in the back where no one can see it. Instead of all on the front of the wall here, it looks disgraceful, absolutely disgraceful. This is Victron Energy official. That guy was talking crap. Anyway, let's get to the point. Dynamic ESS is when you want to sell back to the grid using, wholesale prices. Victron is quite capable of that, but of course, as I was describing, metrics in Australia mean I can't do it. So let's skip dynamic ESS, but that would be great. Drain your batteries when the price goes over X amount wholesale into the grid, make some money. All right. So to finish off, there might be another assistant working in conjunction with the ESS Assistant. So let's Google that. As we've discovered in this learning curve, other assistants were initially considered to be used with ESS Assistant, but no, ESS Assistant is supposed to be a standalone configuration and replace the hub 1, 2 and 4 rather than running alongside them. So there's no need to say set an assistant to turn on the grid after it reaches maximum power of the inverter. It should automatically do it. And that means when I go over there and put this EV charger on, if I get this ESS Assistant set up right, the only reason to hook this up with data to the Servo GX, if there's a spare port left, by the way, is for monitoring. There won't be any control because the MultiPlus will know exactly what to do. Use the batteries, and if the power goes over the top, pull from the grid. So Bob's your uncle. And this can be set to charge at any rate anyway. It doesn't have to max out at 22 kilowatts.
but I would say you could leave it at that. If we get the ESS settings correct, no need for changeover switches and whatnot. Here's a picture of what's going on. We've got some grid side connected stuff. We won't be doing that. We'll be doing this. We'll be putting it on the backup side. Why? Well, just like in this picture here, it can be done. And the reason why it can be done, come on, zoom in. Where's my zoom? There it is. The reason why it can be done is because these inverters have power assist. So if that goes over the top with the power charging rate, 22 kilowatts, and the loads of the house are pulling something, you know, big air conditioner, whatever, turn on the stove, it'll pull from the grid to catch up. And alright, so we've got this thing here. It doesn't seem to have any hard wiring. Here's a Servo GX. Right there, isn't it? Yes, it is. And here's a charge controller and some batteries and whatnot. I haven't used specifically this equipment. But anyway, and there's a Frontiers inverter, haven't used that. Now, so it looks like it's all Wi-Fi, this one. Bluetooth and Wi-Fi. Okay, if that's the case, where do we Bluetooth and Wi-Fi to? That's a good question. Let's have a look. Well, the natural go-to is to pick that one, because it's the only reference to LAN. Local IP address displays the LAN IP address of the EV charging station. Well, is there a LAN connection? Well, there's a lot of pages here. I want to get to the point. Come on. I forgot how many internet ports this thing has. It's only got one. That's already been connected to the house. So that means I've got to get from the Victron all the way to the hub or the router on the house in order to monitor it. I wonder what else I can use. We've got BMS cans for battery, VE can and VE bus. Let's have a look at those. I know they were used for the multi-pluses. Let's go and have a look. Well, screw Wi-Fi, even though this system will be connected very close to the Servo GX, which does have Wi-Fi. I still recommend going cable. And it looks like we're going to use LAN. It doesn't recommend the others, right? So that means to avoid running it all the way back 50 meters to the router in the house, it's going to have to be given another router locally. All right, that's otherwise Wi-Fi. It's going to be in the same garage as the Servo GX. So all right, okay, fine, either or. It's just a Wi-Fi, you know. It's not reliable, is it? Notice how I had to use the AI to find that, because God help me, I couldn't find any of that information in any of their instruction manuals. Classic. Anyway, that's the end of my video. I'll do a review and see if my R&D actually resulted in a success rather than where everyone else is at with Victron. Here, with this sperm, going the wrong way.